Hello, welcome back. So today's video we're going to do another question where we're going to use the limit definition of a derivative, which I have here. So hopefully you can watch the previous videos where I cover like how I got this equation, like how we get to it. And so today we're just going to do a question, and this is the one. So in my opinion, I think this, especially for the AI, well, obviously for AI, this is not required. So if you're not from AI, you might need to know this, but for AI, for sure, you don't. This is really just to like understand a little bit more. I'd say it's like a medium question. It's because this is a long way to do like derivatives. So let's just get to it. So it's a 4-mark question, and it says, consider the function f of x equals x squared plus x minus 3. And find the derivative of f of x using the limit definition of a derivative. So this is the one. So we basically have to find the derivative of this equation right here using our equation that we derived last time. So let's get right to it. It's going to be a little bit long, you might see. Okay, so first of all, let's just do it step by steps. So hopefully, yes, you have seen the video, like previous videos about this, so that you understand a little bit more um, what the actual equation means. But so first of all, for f of x plus h, so this is basically, because f of x is our original function, x plus h, it basically means that for every x that we have in this equation, we need to add plus h. So let me show you how it goes. So here, I'm going to be organizing basically how this equation goes with our specific function that we're using. So first we're going to do f of x plus h. I'm going to do it in this color so that we don't get too confused. So our equation is x squared, but now our x turns into x plus h. So we would write it like this, x plus h, and then this is squared. The entire thing is squared. Oops. There. And then we have our plus x, which we will turn now into plus x plus h. So you see what I did here? This used to be our x, but now it turned into x plus h. And then finally our minus 3. This doesn't have any x's in it, so we just do minus 3. Okay, so this whole expression right here, this is our f of x plus h. Now we're going to move on to the f of x. This one's very easy. It's all about just rewriting the same equation. So, did I? Yes. So here x squared plus x, plus x and then minus 3. So this is our f of x function here. And then we have our h that stays in the bottom. So this is this equation, the limit definition of derivative, but using our equation, our function. So now you might see that this part right here is not really like clear. So we're going to be like simplifying it a little bit. So let me here. So on here, I isolated our f of x plus h section. So you can see it here. This is this part. And so first of all, do you see the blue, light blue color here? This one, you can see we still need to expand it. So this is what we're going to do. So if we expand this, let me copy paste it. So you can see it's basically x plus h, which is squared. So it's timed itself almost. So you can just rewrite it x plus h. Oops. Like this. So I'm keeping the same color so you can keep track of it. So this part right here is just this above part but expanded. And then you might notice that you can keep expanding this part right here, which is what we're going to do. So if you do x times x, let me do it, wait, here. So x, here, x times x, we will get x squared. So let me get it, yeah. Oh, I lost the color. And here it is. Okay, so x squared. And then if you do x times h, you can do here x, h times x as well. So goes 2xh. And then h times h, h squared. Oops. I'm not really going too much into detail about this because this is just normal expansion. Maybe I'll just make another video on this one day. Okay, but so here we have our f of x plus h like section, so just this part but expanded fully. So now it's a little bit more clear. And here we can also take the brackets off, they're not actually useful. Here. So this is this part so far of the equation. So now what we're going to do is we're going to retake this part and plug it back in into our original equation. So let's do that. So if we have the original equation, but now we modified this part right here, so we can just put it in. Oops. How can I do that? Nope. That works. So I'm just going to put back the original color that we had before so that it stays a little clearer. Okay, perfect. So now what we did is we simplified this first part and we plugged it back in into the equation that we had. So clear so far, I hope. Now we're going to move on to this part right here, because you might notice that in the original equation, it's really the f of x plus h, that's minus f of x completely. This is why we still have brackets, because it's not just minus x squared, it's minus the entire part. And so because we're trying to like expand it and make it like easier to solve, we want to get rid of these brackets because otherwise it would get very difficult to like expand. And so there is a trick here, is that because there is a minus that you want to apply to the entire section that's inside the brackets, you can just do that. So you do minus this one right here, but also minus this one, and then this one would also have a negative. But then if it's double negative, it turns into a positive. And so a very easy way to do this is to basically any sign that your like individual component has within the brackets, you just inverse the sign. So for this one, x squared, this one would just turn into minus x squared. The plus x, this one would turn into negative x. And our negative 3 will turn into positive 3. So this is just a way to get rid of our brackets when we have a negative. Make sure you do apply the negative on all of them, because otherwise you might like start losing signs. Okay, so far we got this. Now you might notice that we have some terms that are the same. So you can see here there's an x, here there's also an x. So we can simplify all these, but you can see that they have like different signs, so they could just cancel. So what we're gonna do is I'm just gonna bring it here. So this is the exact same equation, but I color coded it. So you can see here, this is positive x squared, negative x squared, positive x, negative x, negative 3, positive 3. And so these can just cancel each other out, because minus 3 plus 3, that's just going to do 0, and that's not going to affect anything. So let's do that. So x plus x squared and minus x squared, these can cancel. Then our plus x and minus x, these also cancel. And then minus 3 plus 3. So now you might see actually why we expanded this. It's because of this. When you get this expanded form, there are a lot of them, and it happens a lot, that they cancel each other out. And so it makes your equation a lot simpler and a lot less to like think about. Okay, so if we cancel all of these, I'm just gonna bring it in. Oh, no, this is the same one. I didn't write it. All right, let's just, oh no, I did write it. Sorry, there it is. Here it is. Okay, so this is the exact same equation, but you see here I kept the 2xh, h squared, h, and then the h at the bottom. So this is our equation, but simplified with all these terms away. Okay, now I'm just gonna put it back into the black color, and you might notice actually that on top here there is a common term. Every single one of these components has an h. And so what we're gonna do, oops, what did I do? Okay, so right here, you can see I just highlighted all the h's because it's the one like variable that's common to every single one of these terms on the top, so in this area. So what we can do is actually just isolate this h, make it outside, so that just because like it's repetitive to have it every single time. So what we can do is put it outside and make it a little bit simpler. So let me just do this. So you can see I can just start off by putting brackets around it and taking the h out. But so this h right here is gone because we moved it outside. Here there's two h's, so we're basically putting one of them outside. So, oops, just like that. We only have one h left. And then here there was an h, but we took it away, we put it outside. So now we're just left with 1. It doesn't go away to 0 because there's still a factor of 1, so you keep it there. So, great. Now you can see we have this expression here, which is at its simplest form, and we have our h outside. And you might notice why I did that. It's because here there's an h at the bottom, and we can just cancel it with the h on top. So we can just do that now. If we cancel those two h's, now we are left with only this expression right here. And the reason why I did that is because look, if you look at this part that we had here, is if we didn't simplify it anymore, we would have to apply the limit, so all of our h's would go to 0. And if we did that, this would turn to 0, so would this one also, and so would that one. And that would just be 0. And so that's not really what we want, because otherwise we could have just done that from the beginning and gotten 0 the entire time. And so you'll see, by doing this, we'll actually get a real answer, because we know that the derivative of this function, is not 0. It will be something. So this is the main reason. So now I'm just going to bring, so here, this equation here is the exact same one, just after we cancel the h's. So now there's no more fraction, it's just 2x plus h plus 1. And now we can apply the limit rule. So all of our h's approach 0, which basically means that all of our h's are so close to 0 that we just consider that they are 0. So we can almost replace it like that and say this is 0. And so we applied this rule, we can take it off. And so now we can just simplify this equation. So this one is a little simple. So we just, if it's just 0, it doesn't matter, it doesn't do anything. And so we are left with this, that f prime of x, this basically means derivative, is equal to 2x plus 1. And this is actually our answer. So this right here is our derivative. So overall, what we did is we found the derivative of this equation, so x squared plus x minus 3, and we found that it is 2x plus 1. So I'm not gonna say anything, but you guys might want to look at these two equations and notice some similarities between the two, or like some pattern. And I will go over that next time, and I will introduce a much easier way to solve this, because you might have noticed this is very long. This is a lot of work, and there is a lot of um, ways that this could go wrong and that you could make mistakes. So I'm going to introduce a new way next time. So hopefully you can see some similarities between the two. So yeah, I'll see you guys next time.